So that's where the work done by the total force goes. It changes the kinetic energy. Positive work increases it, and negative work decreases it. Now we'll look at the work done by individual forces. Here, suppose that I'm moving the mass so slowly that the change in kinetic energy is negligible. No change in kinetic energy, so the total work done by all forces is approximately zero. Two forces, my hand pushing up, gravity pulls down. My hand pushes up, it moves up, I do positive work. Gravity pulls down, it moves up, gravity does negative work, and the two work expressions add to zero. Where did the work go when I did work against gravity? Note that I can get it back. Well, minus a bit for friction that we'll deal with later. This gives us the idea of stored energy or potential energy. This raised mass has the potential to do work for me. I have stored work in the gravitational interaction between this mass and the Earth. How much work do I store in this gravitational interaction? Again, moving slowly so acceleration's negligible. So the force that I apply equals the weight of the object. Over a distance s, I do work W me equals Fs cos theta. But from this triangle, S cos theta is just the change in height, delta h. So I do work F delta h. Going up, I do work mg delta h against the gravitational interaction between the mass m and the Earth. I'll call this work that I've done against gravity, this stored work, the change in potential energy with symbol U. Because it's equal to work, the units of energy are joules. We've defined potential energy by a change in it, delta U. Let's choose a convenient reference height, say the level of this bench top, and call that the zero of height and the zero of gravitational potential energy. Then we can write an important equation. Gravitational potential energy equals mgh. A warning. I've assumed that g is constant, which is approximately true near the Earth's surface. If I lifted an object 5,000 kilometres, that wouldn't be true. The gravitational force becomes weaker if we go a long way from Earth. More about that in week 8. Remember that the gravitational potential energy is the work done against gravity in raising the object to a height h from the reference height. We can get that energy back, for example, by accelerating an object. Let's check we've got that.